Good morning, students. Good morning, math enthusiasts. Today, we are going to discuss about finding the principal and general values of inverse trigonometric functions. You're familiar with the trigonometric functions. These are the sine, cosine, tangent, cotangent, secant, and cosecant functions. Now, what is a function? A function is a special kind of relation wherein the abscissa or the first element of the ordered pair does not repeat. So if you look at this figure, as you can see, this one is a line, and this is also a parabola, quadratic functions, and this is a circle. Okay, let's just assume that's a perfect circle. So if you do the vertical line test, notice that this red line intersects the function, linear function, at only one point. Also, in the quadratic function, as you can see, the red line intersects the quadratic function at only one point. And so, if this happens, this linear here and quadratic are functions because their first element do not repeat. But here, in the circle, as you can see, the red line intersects the circle at 2 points. So it means the abscissa or the first element or the value of x repeat. And so it is just a relation and not a function. Now, our trigonometric functions, because if you go back with our previous lesson, this is an example of the graph of y. This is the graph of the function y equals sine x. And you notice that if you imaginarily draw a vertical line there, you can see that it will only intersect the curve at one point. So it's a function. Now, let's say function of x is equal to x plus 1. Let's replace function of x by y. So we have y equals x plus 1. And then let's say we put the x variable to the left side and the y variable to the right side. So that means x becomes the dependent variable of the value of y. So we have x equal to y minus 1. X equals y minus 1 is the inverse function. So how do we get the inverse function of the function or the trigonometric function sine? So y equals sine x. Now, the inverse is x equals sine y. So if we have this graph, of course, we simply rotate the graph. And as you can see, this becomes a graph of x equals sine y. Now, if you imaginarily draw a red line, vertical line, you will see that that line will cross the curve at more than one point. So the function here no longer, the relation here is no longer a function. So in terms of inverse trigonometric functions, there is going to be a restriction of the domain so that in this restriction, we can find the inverse trigonometric functions. So these are now the restrictions of the domain. So if your function is sine, then the restriction is from negative 90 degrees to 90 degrees. If your function is cosine, then the restriction of the inverse is from 0 degrees to 180 degrees. And then, if it's tangent, from negative 90 degrees to 90 degrees. And if it's cotangent, from 0 degrees to 180 degrees. And if it's secant, from 0 degrees to 180 degrees. And cosecant, from negative 90 degrees to 90 degrees. Now, notice that we have closed and open intervals there. So you go back to your graphs of trigonometric functions because if you can remember, there were asymptotes in our functions cotangent, secant, and cosecant, and also with tangent. Okay, so from there, we have the principal and general values. So the principal value is always 1 for each problem. But the general values are infinite. So instead of writing all the general values of a particular trigonometric function, an inverse trigonometric function, then instead we rewrite a formula. This formula is based upon these values. So if your function, inverse trigonometric function is sine, then you follow the formula, negative 1 to the power of n times y plus n times 180 degrees. For inverse trigonometric function of cosine, this is the same with that of the inverse trigonometric function of sine. For the inverse trigonometric functions of tangent and cotangent, we have n times 360 degrees plus minus y. And for the inverse trigonometric functions of secant and cosecant, we have n times 180 degrees plus y. Unsa ang y? Y are of course the value of your principal values. Okay? So let's start now with how we are going to get the principal values. So number 1, arcsine is actually a notation of the inverse trigonometric function. Okay, so remember in our previous discussion on trigonometric functions, we write y equals sine x, or we actually write, so recall this, if you're familiar with this equation. As you can see in the previous lessons, we try to get the value of angle theta given the function values 0.2153. So without you noticing, we are actually looking into the inverse trigonometric functions. So how do we get the value of theta there? Then we simply use the arcsine 0.2153. So in this case, we were given arcsine 0.2812. I hope it is still familiar with you how we are going to do that, okay, in our scientific calculators. So if you get your scientific calculators, all you have to do is press shift sign 0.2812 equals, then press the the degree symbol. If you look at the scientific calculator, let us press this one. So we have shift sign 0.2812. Okay, you can press the close parenthesis or not, it is still okay. Then press the degree and you will obtain 16 degrees 19 minutes 54.62 seconds. So our principal value is 16 degrees 19 minutes 54.62 seconds. Now for the next item, how do we get 61 degrees? So press shift cos 0.4705. Then press the degree. So you have 61 degrees, 55 minutes, and 59.67 seconds. Arctan, press shift tan 1.3456 equals, then your degree symbol. So you have 53 degrees, 22 minutes, and 53.9 seconds. Alright, many of you would find it difficult to use your scientific calculators when we proceed with the reciprocal functions, cotangent, secant, and cosecant. Okay, so suppose we're going to get the inverse trigonometric functions of cotangent given the function value 0.13875. So all you have to do is press shift tangent, and then we have 1.3875. Then before you close, press x to the negative 1, close equals. Then press the degree. So you have 35 degrees, 46 minutes, 51.87 seconds. Now with the next second function, press shift cosine, because cosine is the reciprocal function of secant, 14.3801. Then press x to the negative 1 because we are looking for secant and not cosine. Close equals. Press degree. Then you have 86 degrees, 0 minutes, and 44.65 seconds. Lastly, cosecant. So we have shift sine, the reciprocal of cosecant, 24.1923. X to the negative 1, close, equals. So you can see it's 2.36, but we are looking for an angle, so we press the degree symbol. So you have 2 degrees, 22 minutes, 8.48 seconds. So these are now the principal values of the given inverse trigonometric functions. Now we need to determine the general values. So again, as I've mentioned, we simply write the formula. So since we have sine, then we will use the formula for sine and for cosine, and also for tangent and cotangent, and also for secant and cosecant. So these are now the general values. So notice that instead of writing y, we write the values, the principal values as a substitute to your y. So this is it. Again, I would like to remind everyone that the general values are infinite. It could proceed to positive infinity or to negative infinity of angle measures. So what is the essence of the n there? N is any value you would like to substitute. So if you substitute 0 to your n, then what you get is your principal value. Now you can substitute 1, 2, 3, 5, or even 1,000 or 1,000,000. You can substitute -3, -10, or -20, or negative infinity. And whatever angle measure that you will get there, and you are going to get the sine function, it will always come up with approximately 0.2812. That is the same with the cosine and also with the tangent. If you substitute any value for your n, you come up with a particular angle measure and then try to get the tangent function value of that particular measure, then you will still get approximately 1.3456. So let's try now. Proceed to the second function. Sige, let's start with the cosine function. Alright, with the cosine function, let's say n is 3. So we have, just follow how it is written. Open parenthesis, -1, close, then x to the, what's your n? It's 3. 3, then arrow right, press 61 degrees, 55 minutes, 59.67 seconds. Plus, again, you can see there another n. So you have, open parenthesis, para safe, n is 3 again, times 180 degrees. Okay? Syntax error. What happened? Okay, so probably there is something wrong with how we input our information there. Okay, so let's do it again. Press, open parenthesis, -1, close, then input 3, then right, then let's do the parenthesis thing. Para safe, wala tayo syntax error. So you have 61 degrees, 55 minutes, 59.67 seconds, close, plus, open, 3 times 180, close. Okay, so we have a value there, 478 degrees, 4 minutes, and 0.33 seconds. Take note, we are trying to get an angle measure. Now, suppose we would like to get the function value, and let's see if we can arrive at the same approximation. So, you have to remember those values. Okay, so when n is equal to 3, we have the angle measure 478 degrees, 4 minutes and 0.33 seconds. And let's try to see if we arrive at the same approximation of the trigonometric function. Okay, so we have cosine 478 degrees, 4 minutes and 0.33 seconds. Let's see. Okay, so it's 0.4705. Okay, so that procedure is the same with the rest of the given inverse trigonometric functions. Okay, so that is all for today. Remember, math is easy to learn when one learns with enthusiasm. Bye!